All right, everybody. Today is going to be a quick review of solving radical equations. Equations. Help me, having a little trouble already here. All right, so section 4.7, all about the inverse or the opposite operations of polynomials. So we've been studying in chapter 4 things like x squared, x cubed, x to the fourth, so things that have whole number exponents. Today we're going to take a look at what do their opposites look like, their inverses. So radical equations, square root, cube root, fourth root. How do you solve those equations? What kinds of things happen when you look at them? So just a quick review. Again, this is advanced algebra material. It's not brand new for us, but it's things that we should talk about and make sure that everybody has a good understanding of before we keep moving. So for the first part of this, ooh, that's a pretty color. I don't even know how that happened. To solve a radical equation, the first thing we want to always do is get the radical by itself, isolate it. So if you have a radical in your equation that has a variable underneath it, those are the kinds of radicals we're looking for. The ones that have variables underneath. The ones that just have numbers, those are fine. That's just a number. But variables underneath, we get that radical by itself. Second thing we want to do then is we're going to use opposite operations, inverse operations, to get rid of that radical. For example, if you have a square root, that means I would have to square both sides of the equation. If I have a cube root, I would cube both sides of the equation. I use opposite operations to get rid of that. And then last thing, after you get rid of those radicals, now the variable will be accessible to you. You're going to be able to have a variable in your equation that you can just solve for. So we're going to solve for that variable doing whatever we need to do. So check and see, what degree is that equation? Can I just solve for it? Do I need to factor? What am I doing? One thing to be careful of, though, is we have to check my answers. So I got to check the answers in that equation for something called extraneous solutions. Extraneous meaning extra answers. Answers that are not actually solutions to the equation. Why is this an issue for radicals? Well, in polynomials, x squared, x cubed, x to the fourth, domain, all real numbers. Think about those graphs. Parabola, cubics, no undefined places. Everything has a domain of all real numbers. We're fine. Radical equations, not the same situation. Radicals, you can't just plug in anything you want. You're not necessarily going to have a real number answer. So we really have to be careful. It's a little bit different situation when we're solving these. Okay, so let's go through and solve a couple of them and talk through what can happen. We're going to stick our attention primarily to squares and cube roots, but this same process works no matter what the root is. All right, so for a first one, I have a radical in my equation for sure, but it's not by itself. So I have this 7 over here, so I'm going to need to move that over to the other side. So cube root of 9a squared minus 35 would be equal to -2. So now I'm going to pause here and reflect a little bit and think about this. Is it reasonable? Does it make sense? Is it possible that you can have a cube root that's equal to a negative number? Can cube roots be negative? And they absolutely can. If this were a square root being equal to a negative number, I would be thinking, nope, can't have that. I can't have a square root that's equal to a negative number. It's not a real number answer. But for cube roots, odd roots totally is. So again, we've got to be thinking about that domain, like what numbers are reasonable to have here. Cube root, no problem. Okay, so we had our cube root by itself. Now I need to undo cube rooting. So what I need to do then on each side of the equation is inverse operation of cube root, which is cube. So I'm going to do the opposite operation on both sides. This is inequality. We need to keep it in balance. So don't forget to do it on the other side. So when you cube a cube root, you're left with the expression underneath. All right, now we solve. So every one of these, we're going to get an equation that we need to solve for the variable. Just depends on what degree what we do. This is a degree 2, but there's only one variable. I'm just going to solve for it. So I'm going to add the 35. And then I'm going to divide by 9. So I get a squared, equals 3. And then to undo squaring, I'm going to square root. Now when I get down to here, that would be plus or minus square root of 3 then. So plus or minus square root of 3 are my two possible answers. I want to double check and make sure that they work. So you could have done quadratic formula. I have other options here, but if there's just a single variable, just solve for it. Okay, let's check our answer. When you plug in either positive or negative square root of 3 in for this a squared, either a negative or a positive when you plug it in will be positive answer. So square root of 3 squared would be 3. So we have 9 times 3 minus 35. So 27 minus 35 would be -8. Cube root of -8 would be 2. Negative 2 plus 7 gives us our 5. So both of those answers work out just fine. That's what I'm talking about. Check those answers, plug them back in, make sure that they're true. All right, let's try another one. Let's do a square root this time. So check out and see if you have a radical in your equation, and I definitely do. The radical has a variable underneath it, so I know I need to deal with this. I have to get it by itself. Treat the radicals kind of like a big variable. Get it by itself. Isolate that. So I'm going to move the 4 over first. So I have x minus 4. And then I have my radical on the other side. Now, if you compare this back to the last example, there's a couple things that make this one, I guess, a little bit more involved. It's a square root, which doesn't really matter too much as far as difficulty goes. But look at the other side. There's 2 terms over there. It's a binomial. I'm kind of intentionally putting it in parentheses to emphasize that. So if it's a binomial and I'm going to undo here and I have to square both sides, that means I'm going to have to square that binomial. So be careful when you do that. If there's multiple terms and you're squaring, that means this. You're multiplying that binomial times itself. So don't just square each of those terms. It's FOIL. First, outside, inside, last. That's how you multiply a binomial by itself. So x squared minus 8x plus 16. On the other side, when you square a square root, you're left with the expression underneath, which works great. So I got rid of my radical. I isolated it, I got rid of it. A little bit more work to do on the other side. Okay, now take a look at your degree. Every equation you get, you're going to have variables you need to solve for. This is a degree 2, so how do we solve degree 2? Well, you could factor, you could use quadratic formula, you can graph. I think this one works out pretty well with the factoring, so I'm going to go ahead and just make it equal to 0 here and see what I can do. So I'm going to move those 2 terms over right away, and I get x squared minus 10x plus 21, and I think that one's going to work out great. Now, if you didn't want to factor it, you could do quadratic formula, but this one works really well. So x equals 7 and x equals 3. Here's what I want you to do. I want you to pause the video, and I want you to check your 2 answers. I want you to check 7 and check 3 back in the original. So that means actually putting in 7 for x and seeing if that makes sense, if you get a number that works, and then actually put in 3 and try it and see if it works, and check and see if both of those are solutions to this inequality. So go ahead, pause the video, see what you come up with. All right, when you check your answers, what we find out is the first one works out just fine, so x equals 7 is great. X equals 3 does not work. We do not get a solution that makes sense. We get 3 equals 5, not true. That means x equals 3 is one of those extraneous solutions. It's an extra one. It doesn't make sense. It's not in the domain of the function. So be careful. Make sure you check your answers. All right, let's go back over those last 2 types of questions one last time before we do our new stuff. Go ahead and try this one. See if you can solve it through. So if you want to pause the video and try it and then check your answer, that would be a good idea. So we need to isolate first. So we get our cube root by itself. It's equal to 1. Then I'm going to cube both sides, which is going to leave me with the expression underneath. This one, 1 cubed, still 1. Solve for x, we get x equals negative 2. A little bit easier because that's a degree 1 equation. Plug in that negative 2. So negative 2 plus 3 would be 3. Or was 3. Plus 3 would be 1. And then cube root of 1 is 1. 1 minus 6, negative 5. Answer checks out. So for those odd roots, we have much less issues with domain because the domain you can use anything. It's the even roots that are really going to give us issues. Okay, one more like our other even root. Let's try this one. Again, pause the video, see if you can solve it through and check your answers. Then check your work with mine and see how that goes. All right, so we isolate the radical. So I did that. I'm going to square both sides, and be careful when you do that. That's going to be FOIL, so x squared minus 6x plus 9. On the other side, when I square a square root, I get that expression underneath. Move those terms to the other side, and then see if you can solve by factoring. So we get x minus 6, x minus 1. So our 2 possible solutions are 6 and 1. Again, go ahead and plug those back into the original equation. So you're actually substituting in a 6, substituting in a 1, back in the original, so actually doing this, and see if you get a statement that makes sense for each of them. So try it with the 6 and try it with the 1 and see if it makes sense. So check your answers, pause the video, check, and then see what you think. All right, so it looks like the only answer to me that makes sense would be the x equals 6. X equals 1, not true statement. You would get 1 equals, or 0 equals -4. Not true. So the only solution that works is the 6. That x equals 1 is one that we would call extraneous. It's not in the domain of the function. All right, so everything we've done so far, we've isolated a single radical, and we've squared or cubed both sides. Everything works out great. So how is the next one different? Take a look. Our next one, radicals on both sides. Okay, what's the story if you have radicals on both sides? In other words, you have two different radicals that have variables underneath. So I have two radicals that have variables underneath. Well, what you have to do is do the process twice. Get a radical by itself, get rid of it, and then start over. Get the second radical by itself, whatever's left, and get rid of it. So we do that process 2 times. So for us right now, I have an x plus 1 radical that's already by itself. Now I'm just going to show you something here. If I had covered this one up, if that one wasn't there, and say the equation was just this, we'd be in a lot better situation. I know there's radicals on both sides, but what would happen if you square both sides? You get rid of both of them, right? That would be awesome. Happens sometimes. You end up just having to solve an equation with variables on both sides. Not a big deal. With that extra term in there, makes it a little bit more work. Okay, so here's what we're going to do. We're going to square both sides. So over here, that's not so bad. On this side, that means this. You're going to have to do this binomial times itself. That's a 2-term thing. It's a binomial. That means FOIL. So let's go ahead and take a look at the terms. First, you would get 1. Outsides, you get 1 times the square root of 2x minus 12. Insides, you get another 1 times the square root of 2x minus 12. And then last, when you multiply a square root times itself, we get that expression underneath. You would get the square root of 2x minus 12 squared, which is 2x minus 12. Now, I know that leaves a lot of terms, but I think we can put a lot of this stuff together. Some of you are not going to have to show this in 2 steps. You'll just be able to do this. But look at those middle 2 terms. Those are like terms. You have one of them plus another one of them. That would give you 2 of those radical terms. So I have 2 of them. And then I can put the 1 together with the -12. And then I have this 2x term. So plus 2x, and then it'd be a minus 11, looks like. All right, now take a look at the statement I wrote in red. We're down to only having one radical left that has a letter under it, just this one, this 2x minus 12. So when I am going to solve this, I'm just going to start over. I'm going to isolate that radical now and do the same thing again. So I'm going to get that radical by itself. So let's move the 2x, move the 11. So move the 2x, move the 11. That'll leave me with 2 times the square root of 2x minus 12. On the other side, I get -x plus 12. Now, isolate. Technically, I have a 2 there still, right? Now, you could divide by 2 first, and then you'd have a fraction and then square both sides. But what I'm going to suggest is if we just go ahead and square both sides right now to get rid of that radical, I don't think that's going to be too bad arithmetic-wise, because if I multiply this by itself, that means I'm doing this basically. I'll show the work. You would never really need to do this, but this is what you're doing. When you multiply those together, it's not FOIL. These are just 2 terms multiplied by itself. 2 times 2 would give you 4. And square root of this times square root of this would give you 2x minus 12. I think it's easier to do that than get a fraction on the other side. Over here, I'm going to have to do -x plus 12 times -x plus 12. Let's do that FOIL. So first, that would be x squared. Outsides, you get a -12x. Inside, same thing, so -24x. And then last, we get a 144. Okay, so we have a trinomial over here. It's degree 2. Get rid of that parenthesis there. So trinomial over here, degree 2, and then we have some terms on the other side. So it looks like a degree 2. So think about different ways that we've solved degree 2. Think about how we maybe want to go forward here. I'm going to distribute that out. So x squared minus 24x plus 144. All right, well, I think I'm going to move everything over, get it equal to 0. So let's move the 8x, and let's move the 48. So we get x squared minus 32x plus 192 equals 0. Alrighty. Now, I think that a lot of you would probably start like, oh yeah, let's factor it because it's a degree 2. When I look at those numbers though, 192, I'm not sure I'm super familiar with all the factors of 192 right off the bat. So I could do quadratic formula, but let's think about what we did yesterday in class. If you go ahead and type this equation into your y equals menu, so go ahead and type it in there and see what you get. And pause the video if you need to, and so you can put that in there. All right, now I know you can't see the whole graph, and you can mess around with your window a little bit, but see if you can see where it does cross. Looks like it's crossing at 8. You could check in your table and double check and make sure, so you can arrow down and make sure that that's something that makes sense. Is it really actually crossing at 8? So I know that it's a whole number. Yep, there we go, 8, 0. So I know one of my solutions. Now that means one of my factors has to be x minus 8. Is that enough to be able to figure out the other one? All right, well, think about it. You know that these two numbers have to add to 32. So if you know one is 8, just do 32 minus 8. You can find out what that other number is. Or you know they have to times to 192, right? So 192 divided by 8 would have to give you the other one. So go ahead, try either of those. Your other one would have to be 24. Now you could go back to your graph or your table and look for it, and that's fine. But as long as you have one, you are set because now you know what your two possible answers are. They're either 8 or 24. So maybe both of these work. Oops. Maybe both of these work, or maybe only one of them works. Maybe neither of them work. So we really have to go back and check our answers. So go ahead and pause the video, check your answers back in the original statement, and see which one works. All right, so after checking, the only one that works is the x equals 8. 24 does not work. It's one of those extraneous solutions. It's an extra. So just be double checking always on those answers. So isolate the radical, get it by itself, undo it, so do your inverse operation, solve for the variable. So if you have multiple radicals, that means you're going to have to do it more than one time. So multiple radicals with that value on there. All right, so here's the assignment. So you have that up there ready to go. The only ones that are going to be of some issue here are 20 and 22. Those are the ones that have multiple radicals. Just a hint on number 20. This last radical right here is a square root of 3. That is not a radical I'm worried about. There's no letter underneath. These are the two radicals I'm worried about. So you need to isolate one of them. The easiest way to do that would be add the square root of k to both sides. So add that square root of k to both sides of the equation first, then square both sides. Number 22 also has two radicals that have variables underneath it. Neither one of them are isolated. So take one of them and move it to the other side. So if it's subtract, do an add, get that to the other side and then solve. So those are the only ones that should maybe cause a little bit of issue in terms of algebra. Everything else I think works out pretty well. Solving radicals.